question 7 says a rational function has a horizontal asymptote at y equals -3 and a vertical asymptote at x equals 5 with no vertical stretch. Write an equation that best describes this function. I find, at least for me, the easiest way to write this equation is first to remember the transformation equation, which looks like this: y equals a over x minus c plus d. So what I need are numbers to plug in for a, c, and d. So if I can figure out what those are, then I can simply plug those numbers in and I have my equation. The first thing they tell us is that the horizontal asymptote is y equals -3. Well, from our studies, we should know that this is the d value, that the d value of the transformation form tells us what the horizontal asymptote is. So d is -3. Then it says there's a vertical asymptote at x equals 5. Once again, we know what this is. X equals 5 is a vertical asymptote. That's the c value. So I know that the c value is 5. Then it says that it has no vertical stretch. Now the temptation here is to say, vertical stretch is the a value. None means 0, but that's not true. If you were to have 0, that would mean that your graph is completely flat and lifeless and boring, and that would not be what we're going for. That's not what we're looking at. We don't want to do that. Instead, we need to go back to what we've discussed previously about stretches versus compressions. We know that a stretch is an a value that is larger than 1, and a compression will be a value that is less than 1 but bigger than 0, like 1/2 or 3/5 or 11/12 or something. The number in between those two things, 1, that's going to mean that nothing changes. Because remember, when you multiply by 1, it changes nothing. Anything times 1 is that thing. Well, the vertical stretch is all about multiplying the length of something by another number. For example, a vertical stretch by 2 means that you have multiplied the length by 2. Like if it was 1 foot, then it would go to 2 feet. You've doubled it. So what we need is a placeholder here. What we need is that special number that you can multiply and not change anything, and that's going to be 1. So now that I have these, I can just plug them into my equation here. My a is 1. I've got x minus c. c is 5. And then it's plus -3. 3 is my d. If you want to, you can write plus -3, or you can just write -3. That's fine as well.